In this video, we're still going to work with sinusoidal functions and applications. In this one, we'll talk about periodic motion of a clock and then also temperatures of a day. So the hour hand, this first example, the hour hand of the large clock on the wall in Union Station measures 24 inches in length, okay? At noon, the tip of the hour hand is 30 inches from the ceiling. So you can see in my picture that I have drawn that. And then it says at 3 p.m. it is 54 inches. Okay, we can see the sum there, 30 plus 24 all the way across. That gets me the 54. And then at 6 o'clock, they tell us that all the way across here, that's going to be 78 inches. So you can see that that's going to be rotating, and we're going to go from 30 inches away from the ceiling, and then it's going to rotate around. And then as it gets to 3 p.m., it'll get close to it'll get to 54 inches, and then go around all the way down to 78 inches. And since it's circular like this, we're going to get this motion of our sine or cosine wave depending on what we take. Okay, so starting, it says let y equal the distance from the tip of the hour hand to the ceiling. Okay, so we're going to have three distances. I did this like squiggle here because I don't want to do all the units. I know I'm going to have 30 inches away, I'm going to have 54 inches away, and I'm going to have 78 inches. Right? I have that in the y, and then in the x it says, okay, and then x hours after noon. So we have x, and then since we have these three measurements, I'm going to use those increments, like 0, 3 p.m., 6 p.m., 9, 12, 15, 18, 21, and 24. That gets us back around to, gets us a full day, 24 hours. Right? And then we're just going to graph this based on the information they gave us. They said or we can even see it from the graph, at 0 at noon, it's going to be 30 inches. And then at 3 p.m., it's 54. And then we just follow our pattern here, and we see our cosine pattern. Or it could be sine, right? It could be either one. We have to determine which one is going to be easier to set up. All right, so we have that down there. Okay, I think looking at this, and we can see the midline there. I didn't really use that terminology, but right in the middle of our 54 is where our midline is. It's going to go back and forth. And it's circular, so we get this motion. All right, so they asked us to find the equation and sketch. So we just sketched, so we're good there. Now I have to determine, okay, the amplitude I can see is that constant, it's the 24. It's in between here. I can see that 24 and 24 is going to be the distance in between. So I know I'm going to have a 24, but I see that it starts off the midline, which tells me I would rather probably use cosine, because if I use sine, I'm going to have to shift it. So I'm going to put a minus, and I'm going to use cosine since it starts below. Okay, I know that my period, I can see it here, so that's 12 hours, so P equals 12. So if I'm using that backwards, 12 equals 2 pi over B. That tells me that B is going to be pi over 6. That's solving for B. We've hopefully are used to that by now, since we've had to do that quite a bit. This is going to be pi over 6 t for time, or I guess they had us use x. So pi over 6x. I didn't have to shift left or right, so I could just close that off. That's why I chose cosine. If I chose sine, I would have had to shift it. And then I know that the midline got moved up 54 units. So there is my function. Here I'm going to do cosine, if you're curious to see what that would look like. That would look something like this. Be pi over 6. And then I want to move it to the right 3 units, so I'd put a minus 3 plus 54, and it allows me not to have the negative. I just shifted it over. All right, either one of those would be good for that one. All right, let's take a look at another one. This one's a bit vague. I didn't love this. So it says, outside temperature over a day can be modeled as a sinusoidal function. Suppose you know the temperature varies between 68 and 102 degrees during the day, and the average daily temperature first occurs at 10 a.m. So I'm going to do squiggle in both ways. I'm going to do, okay, it starts at 10 a.m., and then if we're just going to assume that it's sinusoidal through a whole day, then I'm going to land back at 10 a.m. Right? This is too vague of a question. Also, we know that it's not for temperature. even though it's a continuous function, right? I don't jump from 70 degrees to 100 degrees. We know that it's not going to be some nice pretty sine function like this. If we think about it, temperature doesn't really move like that. Maybe sometimes by coincidence, but not all the time. So I know 10 a.m. to 10 a.m. The halfway point, and I had to think about this earlier when looking at this problem, was 10 p.m. Halfway through that would be 6 hours. So 6 hours to 10 a.m. is 4 p.m. 6 hours to 10 p.m. is 4 a.m. And then they tell us that it varies between 68 and 102, but the average daily temperature first occurs at 10 a.m. So I'm going to put my first there, and the average would be the mean between 68 and 102, or right in the middle. So that's 170 divided by 2, and that's going to be 85. So the average temperature is 85 degrees. And then they told me the below and above. All right, so we have, this is in degrees. So we'll call it our y-axis, and we'll call this our x-axis. And we'll make our graph. It didn't really ask me for this in the time, and you may be able to just see this. And you would think that it would be a little more complicated than this, but I don't think it is. So if it's starting at 10 a.m., I'm thinking temperature's going up. If we're just assuming, I guess, our normal, how temperature works for us, even though that's not always true, we'll just assume it's not a weird day with a weird temperature change or anything like that. So they asked, how many hours after midnight to 2 decimal places does the temperature first reach 81 degrees? Okay, so they didn't ask us the middle, 85, they asked 81. So I'm going to have to set up a function here, so let's go ahead and do that. My function, I'm going to use sine since it starts on the midline at 10 a.m. And I'm going to make this work for us. Okay, so we have the in between there, the amplitude would be 15 to 17. So I'm going to have an amplitude of 17, and then sine, and then we're going to have to find our period. Well, it took 12 hours to repeat, so the period is 12, which is going to be equal to 2 pi over b. If I solve for b here, b is going to be, again, pi over 6, like that last problem. Oh, it's not 12, it's 24. So it's 24 hours, not 12. 24 hours. If I solve that, I get pi over 12. So I get a pi over 12. And then it got shifted 10 units to the right, and then moved up 85. So what we would do from here, let me erase some stuff. I'm going to scoot this over. Okay, I'll change that because I don't like it that way. There we go. I'm going to take this function that we just came up with, and I'm going to set it equal to, oops, duplicate, set it equal to 81. That's what we want to know. When is it going to be 81? So it's 17 sine pi over 12 x minus 10. And then we're going to minus 85, so we're going to get a negative 4. So we get sine of pi over 12 x minus 10 equals negative 4 over 17. So let's use, I think it would make most sense. Let's use degrees here. Again, this is, oh yeah, it said 81 degrees. Well, different degrees, but we'll use degrees here. It's a little ambiguous, but I'll make sure any assessment problems will not be that way. So we have the arc cosine of negative 4 divided by 17. All right, so that's going to be pi over 12 times x minus 10 equals negative 13.60896063078, and then x minus 10. I'm going to divide by pi over 12, or multiply by 12 over pi. Yes, I guess I could have done division too, it didn't matter. Negative 51.982. 400. Okay, it doesn't look like this is going to work out correctly. Something's up. Maybe we should use radians. Let's try radians. So arc sine of -4/17. Yeah, that one will work out. Let's just use that. -0.23752117078. And then we're going to divide that by pi/12. And we got -0.90726404205. And we got x equals, and I'm just going to add 10 to that. So it's 9.09 is what x would be. And that makes sense because if we take a look at this, let me close this calculator, I don't need it. The function would go like this, down, right, and follow that same shape going this way. Right, the same sine shape, which means that it would hit about 81 degrees at 9:09 p or 9.09. It's not 9:09, right? It's 0.09 of 60 minutes. So it says how many hours after midnight to 2 decimal places. There we go, 9.09. So the degree thing, make sure not to mix up degrees here with temperature and degrees and angles. I think my brain just wanted to go that way. Just use, I think in these models, radians is going to be your go-to typically. That's typically where things go in calculus, is we like everything in radians. But usually what we could do is pick one and see which one makes more sense in context. I think radians is going to be our go-to though.